Today's class we are going to do revision of motion in one dimension chapter. So please write revision physics motion in one dimension. Motion in one dimension. Children, in this class we'll discuss all the important questions from this chapter so we can prepare well with this. Okay. So in this chapter, you should discuss about, you should understand the first thing is nothing but what do you mean by rest and motion. First thing you should remember what do you mean by rest and motion. What do you mean by rest? What do you mean by motion? Second thing you should understand what do you mean by distance and displacement. What do you mean by distance and displacement? Okay. Distance and displacement, you should remember what is the difference between them mainly. Here also rest and motion also you should remember what is the difference between both the terms. Understood? Now, third question they can ask, what do you mean by speed and velocity? Speed and velocity. Speed and velocity also they will ask. Okay. In speed, they can ask first one, what do you mean by uniform speed? What do you mean by uniform speed? B, they can ask what do you mean by variable speed? Variable speed. C part, they can ask what do you mean by instantaneous speed? Instantaneous speed. Finally, average speed. So all the terms are very important. They will ask. Okay. In velocity, first you should study the definition of velocity. Definition of velocity, that is important. Symbol also you should remember. Then next one is nothing but you should remember what do you mean by uniform velocity? What do you mean by uniform velocity? Another term, what do you mean by variable velocity? Variable velocity. Another term, instantaneous velocity. Instantaneous velocity. Finally, what do you mean by average velocity? So this much terms you should study. Understood? This much terms you should study. Another type question. Any one of those terms they will ask for 1 mark. Understood? Any one of the terms they will ask for 1 mark. All this are for 1 mark or 2 mark question. Maximum 2 mark. Now another question they can ask from the section is nothing but difference between speed and velocity. Difference between speed and velocity. This term also they can ask. Fine. Fine. Now another section, fifth section is nothing but what do you mean by acceleration? What do you mean by acceleration and retardation? Acceleration and retardation they will ask. Okay. So in acceleration they will ask uniform acceleration. Here they will ask uniform acceleration. Another term we can ask what do you mean by variable acceleration? Fine. Uniform acceleration and variable acceleration we can ask. One more terminology will ask from this, that is nothing but what do you mean by acceleration due to gravity. Acceleration due to gravity. That also they will ask. Acceleration due to gravity. So children, from the section A, terms related to motion, they will ask this much question. From the section A, terms related to motion, they will ask this much question. These all are direct questions also. They will ask direct questions from this particular topic. That is nothing but terms related to motion. Understood? So prepare all the questions well. Now, if they ask indirect question from section E, how it will come? Indirect questions. So direct questions is nothing but direct definition they will ask. Now, generally, if they ask indirect question, how it will come? Indirect questions. Now, first question they will ask, the displacement can be zero, but the distance is not zero. Why? Generally, they can ask this question. Another question they ask like this. When a body moving in a circular path, when it reaches the original position, after one round, then find the displacement and distance. Find the displacement and the distance. Find the displacement and the distance. Children, this one, the first question answer is available in page number 29. Page number 29. In my notes also, it is available. Already you guys got the notes, right? So it's available. If you guys are absent for those classes, then you can refer page number 29 from your textbook. The first one answer is available there, and the second one answer is available in page number 30. Page number 30. So if you want, you can check the page. Another question they can ask, similar to this one, they can ask, when a body is thrown upward, vertically upward, when a body is thrown vertically upward, and it comes back to the same point. Then find the displacement and the distance. Find the displacement and the distance. Online students, please turn on your videos. This concept also are discussed in the class. Okay. So this answer, if you want, you can refer page number 30 itself. Okay. Fine. Any doubts regarding the questions? Anything? Is it okay? So children, all those answers if you want, the first section answers if you want, I'll tell you which are the page number you should prefer. This one is available in page number 28. This distance and displacement also available. Page number 29. Speed velocity. Speed velocity. All the concept is available in 30 and 31. So all are available in page number 30 and 31. Now difference between speed and velocity, that is available in page number 31 and page number 32. 31 also some topics are available, that also you should read. Then only study the page number 32 because concept type question they can ask. And acceleration and retardation is available in page number 32. All those terms are available in page number 32, 33. So this will help you to study all the concept properly. Children, reading ICC textbook, that is very important. Okay, any guide, anything you can buy, but the easiest method to learn physics for ICSE exam is nothing but read the chapter properly. Okay, now, so these are the important types of indirect questions also they can ask. Now, another questions they can ask. Some general questions we are solving. This is all are available in this chapter. Another question. Numericals. Simple numericals only you can expect from this topic. First one, express the speed 36 kilometer per hour in meter per second. This is the term. Okay. How will you express? I already taught you one trick, right? So 36 kilometer per hour, you should convert into 36 kilometer divided by 1 hour. Now you should convert it to meter per second, right? So kilometer you should convert. So 36 into 1000 meter divided by 1 hour, you should convert second. 1 hour is nothing but 60 minutes into 60 seconds, right? So this is a term we can use. So what happens here? This will become divided by you will get it as 10 meter per second. Am I right? Is it okay? So this type of conversion type questions they can ask. Now, another question. Generally they can ask. This is not numerical, theoretical only. Just write velocity, distance, acceleration, work, mass, retardation, select the scalars and the vector from the following. Select the scalar and the vectors from the following. Okay, we can find that. So which are scalars here? Which has magnitude, no direction, right? So first one you can take distance, work. Third one, mass. Next one is nothing but vector, velocity, acceleration, retardation. Like this also they can ask. Children, direct method they can ask what you mean by scalar quantity, vector quantity. But generally Icse will prefer this type of questions. Okay. Fine. Now another numerical they can ask. Just write the question. A body rises vertically up to a height of 125 meters in 5 seconds. And comes back at the point of projection. At the point of projection. Find first one. The total distance traveled. The total distance traveled. Second one, we should find displacement. That you guys can understand, right? Starting from one point, reaching at the same point. Yes. Next one, average speed. Average speed. And the fourth one, you should write average velocity. Average velocity. Children, before doing the numericals, you should understand how to do numericals. Now also, most of the students don't know how to solve physics numerical. Children, physics numericals is not like maths. Directly, you cannot introduce that. You should introduce what are the terms are given. That is the first thing you should do. Okay, so you can write first thing. Answer should be like this. What are the terms first they are given? They given the first one is nothing but height is nothing but 125 meter. That means distance is nothing but 125 meter. Time also they given. Time will denote it as small letter t. It is nothing but 5 seconds. This much only they given. So total distance travel. That's the first term you should find. Total distance. So if it is necessary to draw, then you can draw also. Children, a body is up started from one point. It reached this point. So this is nothing but 125 meter. After that, it comes back to the same point. Then how much distance? 125 meter only. So therefore, total distance is nothing but S plus S. You'll get 125 plus 125, 250 meter. Understood? Children, once you found this value, you should substitute the unit also. Okay, so here distance is given in meter, so your answer also should be in meter. If it is given in kilometer, your answer should be in kilometer also. You should write based on the question. You should found that. Okay. Next one. What is the second thing you should find? Displacement. Displacement. Children, so displacement, you can understand that this particular body is starting from this point, and it is reaching at the same point, right? It's starting at one point and reaching at the same point. Since displacement has direction and magnitude, direction like this it gone. After that, it is coming back same point. Then what happened? Distance cannot be zero. Displacement is nothing but zero because it reached at the same point. Agil Chandran understood. Now, the third one, average speed. Children, average speed and all, if they ask, you should introduce the equation. What is the equation? Hmm? Total distance traveled by total distance by total time. So what is the total distance travel? You guys understood 250 meter. Am I right? So total time. So to reach A to B, it take 5 seconds, right? So to reach B to A, coming back, it will take 5 plus 5. So it will be 5 plus 5, you will get it as 10. So you'll get it as 250 meter divided by 10 seconds. So the average speed is nothing but 25 meter per second. Now, what is the fourth one? Average velocity. So what is this formula for average velocity? What is the formula for average velocity? Average velocity is nothing but displacement divided by total time. So children, already you proved that displacement is nothing but zero. 0 divided by 10 seconds you'll get. So the value is nothing but 0. Understood? Average velocity is 0 since the displacement is nothing but 0. You understood? Now, another numerical they can ask. Another numerical they can ask. Third one. The velocity of an object, the velocity of an object increases at a constant, right from 20 meter per second to 50 meter per second in 10 seconds. Find the acceleration. Find the acceleration. It's very easy, right? So before doing the numerical, we should write what our terms are given. What are the terms given? Velocity of an object increases constantly from 20 meter to 50 meters. So this is nothing. 20 meter per second is initial velocity, and 50 meter per second will be final velocity, and 10 seconds will be time. So you can write initial velocity is nothing but 20 meter per second. Final velocity you can write it as 50 meter per second, and time you can write it as 10 seconds. Now you should find the formula for acceleration. Acceleration formula is nothing but final velocity minus initial velocity divided by time. Am I right? So 50 minus 20 divided by 10. So 50 minus 20, what is their unit? Meter per second divided by 10 seconds. So what happens here? The second and this one is cancelled. So finally we'll get it as 30 meter. Sorry, we cannot cancel this. I made a mistake. So meter per second divided by 10 seconds, right? So what happens here? This equation will become 30 by 30 meter per second divided by 10 seconds. Now this second is going to the numerator. What happened? 30 ms raised to minus 2 divided by 10, right? So this cancel, you get the answer 3 meter per second square. Acceleration unit is nothing but meter per second square. Understood? That you should remember. Okay. Now another list. We can ask retardation also. Next question, fourth one. A pebble thrown vertically upward, thrown vertically upward with an initial velocity 50 meter per second comes to a stop in 5 seconds. Find the retardation. Children, you should write what our terms are given. So in this particular question, they are asking retardation. What do you mean by retardation, or what is the relation between acceleration and retardation? The negative value of acceleration, we call it as retardation. So listen carefully, children. You can find acceleration on the same formula you can use, but that negative value only you should get. So children, what are values you are getting here? Given initial velocity is given 50 meter per second. So u is equal to 50 ms raised to minus 1. Now, final velocity is not given. Why? Because this particular body will go like this and it will come back, right? So when it is stopping, what will be its final velocity? 0 meter per second, or you can call it as 0. What is the time? 5 seconds. Now you understood why we are calling it as retardation. You will get negative value, right? So acceleration equation, final velocity minus initial velocity by time. So here final velocity 0 minus initial velocity 50 meter per second divided by 5 seconds. So the value is nothing minus 50 ms raised to minus 1 divided by 5 seconds. So what are you should do? The second you should take it to numerator. The acceleration will be minus 50 by 5 ms raised to minus 2. You guys will get. No need to by heart. Directly you can do. So if you do like this, you'll get the value as minus 10 ms raised to minus 2. So acceleration is nothing but minus 10 ms raised to minus 2. So the retardation value is nothing but that value only you should take. No need to write negative value in retardation. 10 ms raised to minus 2. Understood? Negative of acceleration is nothing but retardation. That also showed you. Any doubts? You guys understood? Is it okay? So these are the important questions they can ask from the section A of the chapter motion in one dimension. Understood? They will ask this type of question. So study one. All these questions are important. And why I'm not discuss all the definitions, because already sir taught each and everything I taught by giving notes only I taught. So again, if I'm doing that means it's a repetition only. You guys have the notes, study that. If those notes are not available, page numbers also are provided. Please study that from the page number. Further any doubts, please be free to ask. Got it? Yes. Now, next one. Yes. So learn some more important questions from this section. I'll solve and give some important questions. From section A. From section A. This is all are indirect only. Some indirect question I introduce. So once again, one question they will ask: state whether the following quantity, is a scalar is a scalar or vector. So some quantities they given A. I'll write all the quantities. You should distinguish. Quantities are pressure, force, momentum, pressure, force, momentum, energy, weight, speed. You should distinguish them. So distinguish means children, you should make a table that is better. Scalar, vector. Make a table like this, and it's easy to. So what are the scalar quantity here, which has magnitude only without no direction, without a direction, and which have magnitude. Pressure, that is nothing but scalar. What is the peculiarity of scalar? No direction, only magnitude. So pressure is one value, one term. Another one is energy. Another one is speed. What are the vector quantities? What do you mean by vector quantities? Which have direction and magnitude. Direction and magnitude. Which are the quantities? Force, energy, force, momentum, weight. Why you consider weight? Weight is nothing but force only, right? So weight also you consider. Is it okay? Fine. Now they'll ask another question. When a body is at rest, we know the definition of rest, right? I told you to study the difference between rest and motion. That is the answer for that only. Okay. What do you mean by body in one motion in one direction? What do you mean by body? What do you mean by motion of a body in one dimension? What's the answer? When a body moves in a straight line path, then I can say that particular body is moving in a one dimension motion. When a body moves in a straight line. Understood? Yes. Next question. Next one. Can displacement be zero? This question I already given, but I will solve it. Can displacement be zero even if distance is not zero? Even if the distance is not zero. Give one example. Give one example. Yes. What is the answer for that? Yes. Why? Displacement has direction and magnitude. Distance has only direction. So if you consider an example, you can take circular motion, right? If a body is starting at this point and it is taking a circular path and reach at the same point, then the displacement will be zero. But the distance is nothing but the circumference of that particular circle, right? 2 pi r, isn't it? Fine. Please write that. Yes, the displacement can be zero even if the distance is zero. If the distance is not zero. If you want example, circular motion of a body. Circular motion of a body. If you take circular motion of a body, like this, a body is coming. So here, displacement zero, distance is nothing but circumference, right? You get it as 2 pi r. Understood? So displacement can be zero, distance cannot be zero. Next, one more question I will ask. Generally, this type of questions I'm seeing, indirect questions I'm seeing from this section. When is the when is the magnitude, when is the magnitude of displacement, when is the magnitude of displacement equal to the distance? When is the magnitude of displacement equal to the distance? When it happens? When the motion is in a fixed direction, then both the terms will be equal. Both the terms will be equal. Understood? Another question. Right. Fourth one. Give an example. Give an example of motion of a body. Give an example of a motion of a body moving with a constant speed, moving with constant speed, but with variable velocity. What is answer? What is answer? What is an example? Motion of a body. Motion of a body in a circular path. Circular path. How we understand variable velocity is that, see, circular path, a body is moving like this, right? Now mark, this is a uniform speed. That means constant speed. I'm marking some point A, B, C. This is nothing D. Now its velocity is nothing but the tangent. Velocity is nothing but, here the velocity is nothing but tangent to the circular path. So it's changing at every point, right? Am I right? So under this condition, what happens? The body moves in a circular path. The body will be moving in constant speed, but variable velocity. So if they ask you to draw, you can draw this diagram. Fine. Another question. Fifth question. The value of G. The value of G. What is G? Acceleration due to gravity remains. Children, remember, G means, capital G means it is nothing but gravitational constant, universal gravitational constant. If it is small letter G, it will be acceleration due to gravity. So the value of G remains same at all places on Earth's surface. On the Earth surface is the statement true? Give reason. No, right? Yes, right. No, the value of G, the value of G is not same at all places. The value of G is not same at all places. The value of G, sorry, the average value of G, sorry, the average value of G is 9.8 ms raised to minus 2. It varies from place to place. If you need example, we can take at equator. At equator, G value is minimum. G value is minimum. At the poles, G value is maximum. So it's not same at all places. Hence we are taking average value of G 9.8 meters per second square. Fine. Fine. Generally, I'm asking one question. If I throw one stone and a pencil, vacuum, the medium is vacuum. There is no medium. It's vacuum only. So I'm just throwing one stone and a pencil. Which body will reach the ground first? So both the bodies will reach the ground at the same time. The reason is nothing but since it is vacuum, there is no resistance. Viscous force won't be there. Understood? So both the particles, both the substance will reach the ground at the same time. Fine. Since there is no resistance or viscous force. Okay. So numerical source I'm taking 2 questions. This question is already done. Once again, I'll repeat. First one, the speed of a car. The speed of a car is 72 kilometers per hour. Express it in meter per second. Express it in meter per second. How to do the answer? Children, you guys got given speed is equal to 72 kilometers per hour. So you want to convert this particular value to meter per second. How will you convert? Take 72 kilometer per hour. It will become 72 kilometer per hour. Right. So to convert that, what you have to do 72 into 1000 meter divided by 60 into 60 second. What's the answer you guys will get? 20 meter per second. Don't know max also. Done. One more question we will ask. Express 15 meter per second in kilometer per hour. What is the answer? Just right, given speed is equal to 15 meter per second. Now you should convert into kilometer per hour. How will you convert? Opposite to that, you Opposite to that you have to do. That means 15 meter per second is equal to 15 kilometer now. So 60 into 60 divided by 1000. You guys will get it as 54 kilometer per hour. So children, for this conversion, I'm going to introduce one trick. Please listen. The first trick is nothing but you want to convert kilometer per hour into meter per second. Then what you have to do now? Multiply the value with 10 by 36. Multiply the value with 10 by 36. For example, children, if you want to convert any value, that means 72 kilometer per hour. If you want to convert into meter per second, what you have to do? Take 72 into 10 by 36. How much you'll get? 72 into 10 by 30, how much you'll get? You'll get it as 20 meter per second. Understood? This is my first trick. Now I'm going to introduce second trick. Trick 2. See, if you want to convert meter per second into kilometer per hour, then what you have to do? Multiply the value with 36 by 10. If you want to know this perfectly, you take one example. Convert 15 meter per second into kilometer per hour. Then what you have to do? Take this 15, multiply it with 36 by 10. You guys will get the value as 54 kilometer per hour. I hope you guys understood the trick. So if you want to convert meter per second into kilometer per hour, just multiply the value with 36 by 10. If you want to convert kilometer per hour into meter per second, you should multiply that particular value with 10 by 36. Any doubts? So these are the revision questions from the section A of the chapter Motion in One Dimension. I hope everyone understood. Prepare well and come for next class. Thank you, children. Have a nice day.